Hi, today I am going to start the new topic in the integral calculus, which are the fundamental theorems. Okay, so we will see the four fundamental theorems in integral calculus. Theorems. So, four fundamental theorems. The first, the fundamental theorem of calculus. The second is the fundamental theorem for gradient. The third is a fundamental theorem for the divergence, and the fourth is a fundamental theorem for curl. Okay, we will see all of this one by one, and we will try to prove all of these theorems. Okay, so first, fundamental theorem for calculus. Right. Okay, so let's write this first. So let's say we have a one dimensional function. Let's first draw this function f of x. Okay, and this is the x-axis. Right. So what it says that, and let's say that the curve start from x equal to a and ends at x equal to, let's say, b. So according to that, we have this derivative of this function with respect to x, or the we can say the derivative times dx integration over a to b will gives the value of function at x equal to b minus the value of function at x equal to a. So this is the fundamental theorem for the calculus, right? How we will prove it? Let's see this. So first of all, we will just divide. I mean, let's say that we take the two line parallel to this y-axis, right? And this is the point xi, and this is the point xi plus, let's say, delta x. In the similarly, we are just dividing the whole curve into the different chunks. Okay, in such a way so that the when this line will hit the x-axis, all of those lines will give the equal distance delta x. Okay, so this is delta x, this is delta x, and the next term will also give the delta x, right? Now x in total, let's say total I mean, let's say this x0 is a. Similarly, x1 will be some other point, and that will goes up to, okay, that will goes up to this let's say n, and that xn will be b, right? And x1 can also written as x0 plus delta x. Similarly, x2 will be x0 plus 2 times delta x. In the similarly, xn will be x0 plus, okay, n delta x, right? So this is only for the explaining what we are doing in this curve, right? So one thing that we know that from the calculus, the basic of calculus, we know that if we a curve, okay, so tangent of this curve, okay, so the derivative, or we can say the delta f, let's say this curve is f, okay, by delta x. Okay, so we have this delta f by delta x, right? So what we can write, like what we can write instead of this, for delta f, what we can do, let's say this is a point xi and this is a point, let's say xi plus delta x. Okay, so we can write f of xi plus delta x minus f of xi divided by, for delta x we can simply write the delta x, and when we take the limit delta x tends to 0, and these two lines will come very close to each other, then that this terms will give the derivative. Okay, that term will actually become df by dx. Okay, right, and that is equal to the limit delta x tends to 0, and obviously we will have the same term. Okay, x plus dx minus f of x divided by dx, right. Anyway, if these two lines will come very close to each other, this xi, I mean there is no need to there is no need to add this indices, this I over here. Okay, because the x will become a variable, will a continuous variable instead of this small chunks like variables. Okay, so right, so what now we are going to do is df by dx. Okay, if we take the dx over here, then that will give f of x plus dx, right, minus f of x, okay, by dx times dx, and that will give this f of x plus dx minus f of x. Okay, if I mean we are doing this, right, so this is for the this is I wrote down this equation for the case when the limit is introduced, but if we have not introduced a limit yet, then how we can write the same equation? So we can write this df by delta x, and delta x is f of xi plus delta x minus f of xi divided by delta x times delta x, and that will give f of xi plus delta xi minus f of xi. Okay, now this is the term. Now what we can do, we take the summation of all the terms. Okay, we can do the summation, right, and obviously this is going to be delta fi, because this fi have I mean delta fi will be different for different location of x, right. This delta x is same for all the location of x, but this delta fi may not be same for the all location of x. Okay, so we one thing that I should add initially is that this is going to be delta fi. Okay, so here we have this delta fi, not here. Okay, right. Now it is going to, I will go from 0 to n. Okay, so I think it is a small n. Okay, yes, it is a small n. Now it will give that I equal to 0 to small n f of xi plus delta x minus f of xi.